Lesson 1-4, like terms and the distributive property. Our essential question is, how do you determine if terms are like terms? Like terms. We have two new vocabulary words, like terms and coefficient. Like terms, you may recall from pre-algebra that like terms are terms that have the exact same variable part. So what that means is that if you have terms like 5x and 3x, they have the exact same variable part, the same letter x, so those are like terms. But if you have terms like 3x squared and 5x to the third power, those are not like terms because the variable part means not only the letters, but the letters and the exponents on them have to be exactly the same. So when you've got a 2 for an exponent and then a 3 for an exponent, those are not like terms anymore. The second vocab word is coefficient. The coefficient is the number in front of the letter. So it's the number in front of your variable. So when we look at a term like 5x, the coefficient is just 5. It's the number in front. If we have something like 7x to the third y, the coefficient again is just the number in front, so it's just the 7. Now, we are going to use the distributive property to simplify each expression. So we have 4 examples, and we talked about the distributive property in lesson 1-3 because it's one of our top 3 properties that we have got to remember in 8th grade. So, the distributive property. I'm just going to recopy the original problem, and then we are going to simplify the expression. Simplify the expression using the distributive property. So, we know the 7 is next to the parentheses. It means multiplication. You don't have to see a dot or a little time sign there anymore. A number next to a parenthesis, you multiply. We also talked about how the distributive property means distribute to everything in the parentheses. So if I distribute my 7, multiplying it times 3w, 7 times 3w is 21w. You multiply the 7 times the 3, the w just stays. Then my minus, I keep, and I multiply 7 times 5, which is 35. So my final answer is 21w minus 35. I cannot subtract those because they are not like terms. One of them has a w on it, and the other one does not. So that is my simplified answer. Next one. Same process. I'm going to distribute the 12 times the y and the 3. 12 times y just means 12y. You write them next to each other. The coefficient number goes in front of the variable. This one has a plus sign. 12 times 3 is 36. The third example you may think looks a little bit odd because the 2 is on the right-hand side of the parentheses. Remember that the commutative property says that when you multiply 2 things together, the order doesn't matter. So I could write my 2 on the left-hand side if I wanted to, just like that. So if you like seeing the coefficient, if you like seeing the number 2 on the left-hand side instead of the right-hand side, go ahead and rearrange that order. Now distribute. 2 times 8 is 16, plus 2 times 4n is 8n. And last but not least, I'm going to change the order right away on this one. And distribute a negative times a positive is a negative. So -6, then a negative times a negative is a positive. So this would be a positive 15Q. So this sign right here is a minus sign or a negative sign. 2 minus 5Q is the exact same as 2 plus negative 5Q. So I am treating that minus sign as a negative on my 5 so that when I multiply the two negatives together, I get a positive in my answer. Next, we have 4 more examples. In the classroom, we would have students volunteer to do these. I will just solve them quickly because they're just like the examples on the last slide. The first 2 are straightforward, and then the bottom 2. Both of those end up being negative because it's a -2 times 2 positives. And then the bottom one, like that. Okay, identify which terms are like terms. In the class, we would volunteer and have students come up one at a time to click and drag. If I click and drag the 4 into this circle, I have to put only like terms in that circle with it. So I know that the plane number 22 would be a like term. I don't see any others. 6y would have to start a new circle. The 9y can go with it, and so can the 4y. 5x starts a new circle. 13x can go with that. 7x squared and plane x squared can go together. And 7y to the third is all by itself. Remember that the variable part has to be exactly the same in order for them to be like terms. So x squared is not the same as a plane x. Y is not the same as y to the third. And the plane numbers that are like coefficients only, constants, they're on their own. Okay, now more complicated. Problems like these, where we've got a lot of different terms up here, are a little bit trickier. I like to identify my like terms first. So I'm going to look at the problem, and I am going to mark the ones that are alike. And notice, I'm keeping the signs in front of it. So I've got 3x plus 2x, which would be 5x. When you're adding together like terms, you add the coefficients. You don't change the variable part of it. The variable part is what you look at to determine if they're alike. Then if they are, you add or subtract the numbers in front. Plane numbers, like this +5 and +6 are like terms. So I can combine those two. They're both positives, so I get 11. Next problem. Notice on this one, in front of the 8x, there's a minus. So 10x minus 8x is 2x. And then +2 combined with a -4 gives me a -2. So you have to be careful with your integer operations when you're combining your like terms. 12b to the second minus 8b to the second is 4b to the second. Don't change the variable part of it at all. And the +6b that doesn't have any like terms just follows. Typically when you work with combining like terms on problems like these, you want to start with the highest exponents on your variables and then go down to the plain numbers. So that's standard form is what that's called. So on this next example, I'm going to start with 4y to the third, even though it doesn't have any like terms, because it's the highest degree term. Then I've got plus 2y and minus 8y. Combining those gives me a negative 6y. And last but not least, plus 5, my constant. Okay, the last example, when you've got different variables, there's not really a rule. I'm going to go with alphabetical order. So I will start with 15x minus 7x, which would be 8x. And then the other two don't have any like terms. So minus 2y, and then plus 3. Again, the order doesn't matter as long as you've got the correct signs in front of each of your terms. The order that you write them in doesn't matter. Standard form we'll learn about later in chapter 7. That's a little bit easier to work with if you've got them from highest to lowest. Okay, last but not least, putting everything together. Now we're going to do some distributing first. We have kind of a lot going on in these problems, so we're going to take our time. So I'm going to distribute first because I see a 7 next to parentheses. So distributing would give me 21x plus 28. Then I can bring down the 3x and the plus sign that were in front. Now I'm ready to combine my like terms. The two at the x's are the ones that are alike. Adding them together gives me 24x, and then I've got my plus 28. Those are not like terms. It's not 52x or 52. It's not 52 anything. They are separate. One has an x, one does not. Final answer. Next one. Distribute first. Now I'm distributing the 4. 4 times 2x is 8x. Plus 4 times 3y is 12y. Bring down the plus 5x. Combine your like terms. 8x plus 5x. 8 plus 5 is 13, so 13x plus 12y. Final answer. Letter C. Distribute the 2, and you get 10x minus 6y. Bring down the plus 7y. And what happens when I combine my like terms here? I notice I have a minus on the 6y and a plus on the 7y. So it's going to give me 10x plus just 1y. When it's just 1y, you don't have to write the 1 in front of it. You can if you like to, but you don't have to. I'm running out of room, so I'm going to group this and shrink it. So I can fit one more problem in for you. I did not want to skip this one because this one has a negative sign on the 3. And it's got a little bit more going on with like terms. So if I distribute the negative 3, I get negative 3x, and then remember positive 12, because there's a negative on the 4 and on the 3. A negative times a negative is a positive. Now I've got 2 sets of like terms here. My like terms with the x's would give me 3x if I combine them. And my like terms that are constants, if I combine them, I get plus 22. So 3x plus 22. So distribute first, then combine your like terms. And combining your like terms involves only adding or subtracting those coefficient numbers in front. You're ready to write your summary, so please go back to your essential question and reread it, and then write a summary, complete sentence, that would answer that question. Remember, restating the question as a sentence starter is always a great idea. And here are your homework problems for lesson 1-4.